Okay, so let's do an example here. Uh, let's imagine, y'all have seen these movies, the zombie movies and so forth. So you've got a group of teenagers out here, and they are going through the forest, and they see this empty hole in the ground. And the hole is a depth of 25 meters. And so they always in the movies do something stupid, and that is they lower one of their friends down into the hole. Okay. And so the friend is down in the hole, and they pick someone light, so they'll probably pick a girl that's like 51 kilograms, lower her into the hole, and a rope, and let's say that the rope has length 25 meters, so it's barely long enough, and has a mass of 1.75 kilograms, so like a nylon rope or something. And so as she's standing down here, she turns on a flashlight and sees zombies coming after her. Okay, and so she screams. Okay, and so as she screams, she shakes the rope, and she told the people upstairs when she shakes the rope, then when they feel it, to pull her up. Okay, so the question is, how long does it take for that to make it up to the top? Okay, and so we're gonna try this two ways. First of all, let's say that she's hanging on the end of the rope, and secondly, let's consider what happens if she's just standing beside the rope and then start shaking it. Okay, the first situation here, because this is the easier one, is that they lower her down here and she's hanging on the end of the rope without touching the ground. Okay, and she sees the zombies start coming towards us, and she vigorously starts shaking the rope, and a wave goes up here. And so we want to know, how long does it take for the wave to reach the top? Well, the time is going to be equal to the distance d divided by the speed of the wave. All we have to do is find the speed of the wave. Well, we know that the speed of the wave is square root f over mu. So, free body diagram, F is the tension in the rope. Well, got the rope here, we got her hanging here, and so we got mg pulling down, and so we got this tension pulling up, and so we can imagine the tension equals mg. And so that would be, now this is not going to be exactly right, but let's just pretend, 51 kilograms times 9.81 meter per second squared, and so that comes out to be 500 newtons. And what is mu? Mu is the mass per length of the rope. So I said that the rope had a mass of 1.75 kilograms and had a length of 25 meters. So this comes out to be 0.07 kilograms per meter. And so the speed of the wave is going to be 500 newtons divided by 0.07 kilogram per meter. And so that comes out to be 84.5 meters per second. So this is 25 meters divided by 84.5 meters per second. And so it takes about 0.296 seconds, so less than a third of a second, for that wave to reach the top. So this depends. Is this the old zombies that were staggering and slow, or the newer zombies that run? Okay, and so that determines whether she survived. Okay, well, the other case, what if they lower her all the way to the ground, and she's standing down here with one hand on the rope, and then she sees the zombies coming at her, and now she waves the rope, and the wave goes up? So what has changed? Well, the time is still distance over speed. Okay, the distance is still 25 meters. Mu is the same. It's the same rope. So mu is 0.070 kilograms per meter. The difference is now the speed of the wave, square root F over mu, the tension's different. Now the only thing pulling on the wave on the rope is its own weight. So that means the tension is just going to be equal to mg of the rope. Okay. Well, the problem is the top of the rope holds the entire weight of the rope. The middle of the rope only holds the bottom half of the rope, and the bottom of the rope doesn't hold very much of the rope at all. Okay. So that means that the tension actually varies as you go. Okay. Because the mass varies linearly with height, the tension is varying linearly. So we can find in the middle is going to be the average tension. So the average tension is going to be 1/2 of mg because it's half of the mass there. So that's 1/2 of 1.75 kilogram times 9.81 meter per second squared. And so that comes out to be 8.58 newtons. So C is square root of 8.58 newtons divided by 0.070 kilograms per meter. And so now, standing on the ground, just shaking the rope, the speed is dropped to 11.1 meters per second. And so the time is going to be 25 meters divided by 11.1 meters per second. And so that's 2¼ seconds. Okay. So at that point, we assume that the person lowered into the ground gets bitten by a zombie. Okay. And then when they pull this person up, then they bite the other people here and spread the zombie plague and initiate the zombie apocalypse now. Okay, so anyway, y'all have seen these movies. Okay, they always do the worst possible case here. And so now we have a zombie example. You probably never thought you'd be doing a zombie example problem in physics.